Can I say something real quick to Joyce?
Joyce, sorry, we've been going over some of the earlier ones, but I forgot to start taping. So we're starting at number 11. If you have any other questions, just let me know. And then I need your t-shirt size or sweatshirt size, depending on what you want. Okay. Number 11.
Joyce, if you're angry that we forgot to tape, tweet us about it at Miss D.
Yeah, that was a good one.
HCS. Okay, so letter C says, is it C or D? C? What is the fewest number of times at which L prime must equal 0? Guys, hold on. When you see or hear L prime equals 0, what should be the first theorem we can get?
Stream value theorem.
Not a stream. MV, kind of MVT, but when's it going to be 0? When the average change is 0, when you have two endpoints be the same.
Yeah.
Right? So rolls, ultimately. But it's a special application of MVT, so you could just use MVT and then look for rolls. But wait a minute, rolls, you have to have 2 points be the same.
Yeah.
There isn't any, so there must be another way. But if there was 2 endpoints that were the same, we'd be like, golden, we see one. But we have to think beyond that. So MVT and IVT. MVT and IVT. Because, long story short, if it goes from 120 to 156, since there's an average increase, right? Since there's an average increase, there has to be at least one place where the derivative is positive. And then from 156, oh, okay, well, average increase, all I know so far is average increase from here to here. Positive derivative at least once, probably more than that. And then, ooh, a negative. So if I can say by IVT and MVT, since there's an average increase, the derivative has to be positive somewhere. Average decrease, derivative has to be negative somewhere. And since this is motion, which means it's differentiable, then the only way to go from increasing to decreasing in a differentiable way would be at a 0. Could be a sharp point. That's not going to be differentiable. So I can say, sweet. Because of MVT, the average increase, average decrease, there has to be a derivative positive, negative. By IVT, I know it has to be 0 in between the positive and the negative. But that's 1. Now keep going. Decrease to increase. Hey. Alright. By MVT, average decrease, average increase.
Yep.
Has to be a 0 in between. And then average increase, average decrease, 0 in between. And then, oh, just decreases again. So how many do you guys count? Up, down, there's 1. Down, up, there's 2. Up, down, there's 3.
3.
3. And then in parentheses put by MVT and IVT, you just have to work it out in the sense of, now make sure you don't say that derivative is increasing from 0 to 3 because, or the derivative is positive from 0 to 3. Do we know that for sure? No. But we do know there's an average increase. The derivative has to be positive somewhere in between 0 to 3. Does that make sense, guys? And then similarly,
how does
negative
IVT fit into all of this?
Because IVT says if I have a positive and a negative, there had to be a 0 in between as long as my derivative was continuous, which it is. IVT in between.
Intermediate value theorem.
So if you have a negative and if you have a positive, there had to be a 0 in between. Or if you had a positive and a negative, there had to be a 0 in between.
Well, that makes sense. I don't remember that being on the forever.
It is on the forever card.
Is it right there, Becca? Huh? I definitely didn't see it.
It was hiding behind. Sorry.
Oh, no, sorry.
YOLO.
Still have until tomorrow. Okay, so that's okay. We're good. 11D, do we need? Okay. 12, C? Evaluate 0 to, oh, not C. Do we need something from 12?
All of it.
All of it, the pole of T. Well, hold on. Temperature, approximate, average rate. We just do a slope, right? So go find 3.5. It's not in the table. Great. Use the 2 points straddling 3.5 and do change in Y over change in X. Average rate. Average rate.
Alright.
Letter B, explain the meaning. Don't you guys see average? Average value of who?
The whole shebang.
Of H, yeah. And who's H? Temperature. Sweet. Average temperature.
Wait, is the integral of H, would that be like the rate of change of temperature? Wouldn't that be like
No,
degree-
wait. This formula, 1 over b minus a to b of, is the average value of the integrand.
Yeah.
This formula is the average value of the integrand. Who is the integrand? H. So it's average. Who's H? Temperature. Done.
Oh.
Does that make sense? If we fit it in? So it's going to be the average temperature of whatever, the pot of tea in degrees Celsius between 0 to 10. Cool? Trapezoidal sum, you have to actually use your table. 1/2 base times height 1 plus height 2. Kiddos, hold on. Would you have to do 4 separate? Or could you do the trapezoidal rule and lump it all together because their bases are the same? They're not the same. I'm going to have to do a trapezoid with a base of 2, trapezoid base of 3, trapezoid base of 4, trapezoid base of 1, right?
The step has to be the same.
In order to be able to use the rule. Does that make sense? Letter C, 0 to 10. How do I find fundamental theorem of calculus? How do I find the integral from 0 to 10 of h prime?
Plug in
H of 10 minus h of 0. Perfect. And then what is it going to be? This is the integral of the rate, which means the change in temperature, right? The overall change in temperature from 0 to 10. And technically it'd be how much the pot of tea cools overall, right? And then letter D, biscuits. I remember this year the kids hated this one.
Biscuit.
Biscuits. They were like, tea and biscuits, it's awful. Not that bad.
Wait, this was an AP test?
Remember the year? That indicates an actual year of AP.
Oh.
What year was it?
That was 11.
What year was that?
That would have been
That your
First
first
year
year?
back?
5 years ago.
No.
No, but first year BC.
Oh, this was on AP. I am
Oh,
on
it was
BC yet. Because remember, maybe I told you, ABBC share
Right.
4 or 3 FRQs? I think 3. Share 3 FRQs.
We-
That's why they're at the exact same time. Because if they weren't, then okay. Biscuits start off at 100. That's the initial, right? Removed from the oven. The biscuits are cooling. The pot of tea is cooling. The temperature of the biscuits is modeled by an equation using the given time models. So you need to figure out how cool are the biscuits at 10. But haven't you already figured that out in letter C? So you can figure out what the temperature is of the tea from letter C, and the biscuits, all you gotta do is 100 plus the integral from 0 to 10 of b prime. Sure. Initial temperature plus the change in over the time interval. Compare the two numbers. Who wins? Okay. Number 12, we're done. So, kiddos, go ahead and let me come by and pick that up, and as you do, close everybody. Let's go ahead and section 8.2. Did you guys have any other questions? I know George asked me one earlier. Did you guys want to look at that one real quick, or should we just go?
I just had one question on it.
Can we check the even?
What page was homework?
402.
Okay.
Just number 40 then.
And then check the evens real fast. Okay, let's go peek at while the evens are coming up. 49? Oh, struggle. He's definitely not this page.
Yeah, it was. Oh, wait, are we doing the evens or are we doing?
Evens are on the other one. Hold on. Amanda's question is 49. All right, what'd you guys do for 49?
Misty.
Yeah.
Maggie made me give her one of my Charlie Brown's pens.
Ah.
You're so mean.
Huh.
Which one?
Oh, hey, P.S. I sent out the support letter info for
Yeah, I
you and
got
Maggie. I would do it together, right?
Yeah, I got it.
Okay, but like for you guys, I do it together. We'll just give you one code.
Yeah, I don't know if we're gonna do it though. We don't have anyone to send it to.
Oh, really?
Yeah, we never
Family
do.
or church people?
No.
Right, so they're gonna come help and stuff.
Yeah, probably. I'm gonna do the SI thing.
Yeah. Find the positive value of k such that the area of the region enclosed between the graphs of is 2.
Oh, I can do this one.
Well, what are we supposed to do? Walk me through.
Okay, so you have to find the zeros.
So you said
You said they're equal to each other. And then,
K's don't matter, right?
And then you subtract the cosine, and you can graph it, and then it will find it.
Yeah, find the zeros or find the intersections. What intersections did you find them?
It was some two. They were two decimals, and I stowed them as A and B. You notice I was talking to myself on.
Yeah.
It was like it was plus or minus 0.824132.
Stow it, and those are going to be your bounds, right?
Yeah. That's
So
what
we
it
can
is.
say that this equals, we'll say, yeah, AB instead of X. So between A to B. If we do absolute value, it doesn't really matter, right?
Mhm.
Technically. So we can do our K cosine X minus KX squared
Keep those up.
equals 2. There we go. Then we could pull out the K, we can solve for the integral, and then make it a positive and do 2 divided by. Isn't that cool?
Yeah. That one was fun. It's actually figured it out by myself, and I'm so proud of myself. I never figured these out.
So K equals 2 divided by the absolute value using your intersection. Alright, evens. Where do we start off?
4.
4? Alright. Number 4. Final answer, 4/3.
24 after that.
4/3.
Mm-hmm.
And then remember, guys, if you have your colored pen, just for grading purposes, just put a little check if you get them all right, right? Otherwise, I don't know you graded it.
Oh.
24. Final answer is 4. Number next one.
Actually, never do.
52.
52.
Sorry. Final answer is A.
This is the one.
Oh, that's multiple choice.
Yeah, but this is the one you have to look at the graph to see which one was greater, because you can't just use a shortcut with absolute value.
And then 54. But
Sorry.
well, what did you put in your answer?
54 was B.
1.827.
54 was B. 52 was A.
Who are you?
54 was B. 52 was A.
Oh, shit. You probably get to do it by hand. That's fine.
Did I give you all? Yeah, I gave you all the multiple
Yeah,
choice.
52 and 55.
All right.
And now let's.
All right, section 8.3. The nice thing is, did this not save from yesterday? Little punk. Okay. Somehow my computer crashed. We didn't get to save it. That was homework number 29.
30.
30. It saved most of it, but it didn't save my final changes. That was 8.2. All right, since I'm here anyway, let's grab him. There we go. Sorry, Lo Santo.
Better be.
Whoa!
Oh, of course.
Whoa! Oh, I gave you guys 55 also?
Yeah.
But we don't have a choice for that.
No, but since I already have it open, I figured for next year. I hate the snipping tool. Alright, kiddos, section. You don't need to see all this. 8.3.
Do you screen it? So just pictures here now. I'm writing pictures.
You guys can get at least the title and stuff down, yeah?
Yeah.
Okay.
If you do pages that we can.
Oh, dual page it.
That way we can connect.
Good call.
They don't call me Peyton Manning for nothing.
What? You guys don't have to draw the pictures. You guys don't have to draw the pictures, right? No, we
I
don't.
have to do a full on like absolute.
Oh, do you see how slow my computer is? This is such a struggle. Okay.
What was the section, guys? Do you like write it there and then write any table of contents right after that?
Depends on whether or not you forget for the test. To be completely honest. is out today.
I'm not waking him up at the end of class.
Who's gonna do it?
Not me.
I already woke someone up today.
Who? Oh, that's your experience. You doing it.
Halsey?
Yeah. She fell asleep in Iowa. Yeah. First time.
English.
Yeah. Pretty didn't have the first period.
Okay, then.
Thanks for letting us.
Because I know everybody's.
I don't.
Oh,
She,
know it.
I just remember that she told me that. Okay. She came in late. I was like, what happened? She was like, oh, I don't have first period.
Good story.
Are you guys good?
no.
Oh.
I didn't go.
But I can't read the other stuff, so and I don't think it's important. So yes, I did.
So kind of yes. That's helpful, thank you.
SD, my Snoopy stamps leave a weird residue around the stamp.
What do you mean?
It's like weird.
Around the stamp? The stamp stamp?
Yeah, like where I stamp it.
Oh.
You see? It's like greasy.
Hold on, why didn't I
I got bored.
That's hilarious. Okay, let's go back.
Who's this?
So, volumes. Last year, what do you remember?
What?
I remember I didn't understand.
Oh no!
I remember we took an
that volumes are hard
FRQ.
to remember.
I remember that we took an FRQ, and then it was like right on that, so everybody aced it. And then when we took the FRQ on the AP test,
No.
and it had that, and nobody remembered it. Like a few of us remembered it, but that was it.
It was really sad. Okay, so what's the idea? What's the idea? What's the
Thumbs
idea?
up.
What's the idea?
What happened?
We were
Sorry.
talking about who's going to wake you up, Sam. That's why they're laughing. Okay. Section 8.3, volumes. How does, where does pi r squared h come from? Who is it?
Volume of sphere.
Is the area is
Cylinder.
That's 4/3 pi r cubed. About what?
Cylindrical.
Of a cylinder. Cylinder. Okay. So think of a can soda pop. There we go. Or like a Pringles can.
I love those.
And from my keys. Okay, so coming back. Pringle can, right?
Mm-hmm.
Where does pi r squared h come from?
I thought you take all the area, all the cross sections.
It's area times height. But why is it area times height?
You take one area of a cross
It's
section and
the-
multiply by all the cross sections.
Area is the two-dimensional, right? The two-dimensional measurement of what's in the circle. And then height accumulates it all the way through. True? And then it builds the third dimension in a sense, or it gets the three-dimensional measurement, okay? So what's going to change when you get to loaves of bread or watermelons or oranges or strawberries or other things that need accumulations of sizes or of slices? Oh, wrong way. There we go. We can find volumes of irregular figures, but since in each of these, not each of these, the middle two. In the middle two, since the slices are different sizes, we can't just say side squared times height, right?
Right.
Because that would be a rectangular prism. We can't just say pi r squared times height because that would be a cylinder. This one's okay because the slices are uniform, they're constant, so we can literally just do pi r squared h. But these ones we need something additional. The nice thing is with pyramids and with spheres, someone else has done that work for us. So we know that a sphere, for instance, the entire thing is 4/3 pi r cubed. Same thing with the pyramid, we know it's 1/3? Yeah, 1/3. Side squared, if it is a square pyramid, side squared times height. Right? But long story short is we're still going to need to accumulate, but especially when the shapes are changing, or I should say the sizes are changing, then we're going to have to do some calculus to help us with that accumulation. Now, that brings us to steps to solving by cross sections. Now, my ones that have done these before, how do you know it's a cross section problem as opposed to a revolution problem?
Well, one in the revolution problem is see it like it'll say it's spinning around the.
Something about revolving about. So if it doesn't have revolving about, okay, that's one thing. But then another thing, it would say something like,
With the width.
slices, or what's the synonym for slices? Much more mathematical.
Cross section.
Cross sections of. Now that might not be that specific wording. It could say rectangular cross sections, like might come before. But what are some different types of cross sections you might see? Circles, yes, of course. Semicircles. Those ones are a little bit rough.
Squares. Or rectangles.
Squares, rectangles, relatively same. Equilateral triangles. Nice thing is they've given us those, I think they've always given us those area formulas. Not for squares and rectangles or circles, although AB wishes, sadly. So that's the wording that we're going to see. We're going to have to identify the bounds. Maybe once again they're defined. Maybe they're just natural because we're going to find we're going to find the intersections. I need to finish my thought. Determine the slice means determine the shape of the slice. And why do we need the shape of the slice? Because we need to find the area formula, right? We need to find the area formula for whatever we're given, like circles, right? Pi r squared, semicircles, 1/2 pi r squared, squares, side squared, rectangles, base height. Equilateral triangles. Has a square root in it with a side squared.
I know what you're talking about.
I don't remember what it is. But we can actually derive it from geometry. I did it last year. Yeah, it was fun. Okay, so determine top, bottom, or right, left. What does that mean? Dx, dy, and as a result, a of x or a of y, right? So we're going to not only need to figure out an area formula, but also get that area formula either in terms of x completely or in terms of y completely. Then set up your integrals and solve based upon what or who? Our formulas. Oops. Our formulas. They're there. Oh. Wait. Do you need this page?
Respect to x? No.
Yeah.
We just talked about with respect to x or with respect to y. So for visualizing, if your slices are moving horizontally, they're going to have horizontal thicknesses. Yes. If they're moving vertically, this is x, y, z. If they're moving vertically, then the thickness would be dy. So that's how you can kind of attach it as to whether we're going to have it in terms of x's or in terms of y's. The same way the representative rectangle had a thickness, now these areas will have a thickness, and that's going to determine. And that brings us up to our, formulas. Formulas for cross sections, right? Now, section 8.3 doesn't just have cross sections. What else does it have? Revolving. And then as soon as we have revolving, just to give you a peek as to where we're going, we're going to go real quick discs, real quick, one example, washers, and then real quick, that's fun, washer example, yay, yay, yay. Then we're going to go with, wait for it, oh no, where are they? Shells.
Cylindrical shells.
Shells are fun. But wait a minute, I have something to show you that you didn't really understand.
The thing I was playing with last year?
Last year.
On the shelf?
Is it the one I broke? By
It's not
accident,
on
that
the
was not
shelf.
my fault.
Where you go?
It's not on the
No, it
shelf?
wasn't the one you broke. Oh, where is he?
Is it on the shelf?
Are we turning in the packets?
I don't think it's on the
Keep it
shelf.
over here.
Here he is.
Oh, you found it?
Aha.
Whatever.
I like square.
Could he be a washer? Yes. But couldn't he also? Cylindrical shell, cylindrical shell, cylindrical shell, cylindrical shell, cylindrical shell. Now imagine these being infinitesimally thin and not poorly made because they're made to be smooth when they should be flat across to show the error, but that's okay. We can get volumes from cylindrical shell.
Did that just go in a circle? Did it just start where it ended up? Ended up where it's
I was showing you that it's comprised of cylindrical shells. There you go. That's cool. Alright, anyway, we're going there tomorrow, so be ready.
Turn in the packet?
Give me your packet on the way out the door. Bye, guys.
So homework is due Monday.
Cool. Homework is due Monday. Which is nice for Sparkle people.
I'll turn it to you later. Yeah, probably tonight. Today.
Great job today, guys.
Sam, what size are your shirt size? Large, medium.
Okay, let me explain. By the eventual time at which I arrived at this point.
Hold on, I'm pausing the video because I only have so much time. Yes.
Like, comment, subscribe.